All right. Talk about solving inequalities. All right. So really, a lot like solving equations. So we won't spend just a ton of time here tonight. But there's just a little bit more that we'll need to cover with that. So let's just solve that. So it just means get x by itself. So what would we do here? First move. Subtract 7. 3x is greater than 13 minus 7 be 6, right? And then divide by 3. The only thing we need to keep in mind when we're solving inequalities as compared to solving regular equations is if we multiply or divide by a negative number, got to flip the symbol around. We didn't do that on this one, but it does happen some. So if we multiply or divide by a negative, you need to flip your inequality symbol. You need to keep that in mind. Now, that's the answer in set notation is exactly the inequality that you get. So set notation is that. Interval notation, that's the ones with the brackets and the parentheses and stuff. So x is greater than 2, so that means all the answers are bigger than 2. So that's going to go from 2 to infinity. Is the 2 included? No, it doesn't have an equal to mark, so the 2 is not included. So we'll use a parenthesis. Okay. And then one other way that you might be asked to show the answer is on a graph. And that would be a number line graph. Not a coordinate plane, but just a straight number line. So 0, 1, 2. And the way your number lines are constructed is you're going to look at that number, and it's a lot like the interval notation. If its x's are greater than 2, then it's going to go this direction from the 2. And you're going to put a parenthesis across the 2 like that, and then your shading goes to the right.
Did they used to teach circles?
Open circle, filled in circle, yeah. Yeah, that in they actually still do in most high schools, open circle, filled in circle.
So it would be better if you parentheses on the 2 or after the 2?
On the 2.
On the 2.
On the 2. Okay. So we get 3 different ways to express our answer: set notation, interval notation, and then a graph, and be able to work between those one way or another. Out of that, let's look at example B. Let's say we had something like negative 3x plus 5 is greater than or equal to negative 7. Let's get x by itself. Subtract 5. And there's negative 3x is greater than or equal to negative 12. And then what do we do to get x by itself here? Divide by the negative 3. We divided by a negative, so we have to flip our symbol. And then that's going to be positive 4. Anytime you multiply or divide by a negative, you're going to flip that inequality symbol. Let's get our 3 forms. The set form, just straight up what you've already gotten written down. The interval form. If all the answers are less than or equal to 4, where's it going to start at? All the numbers are less than or equal to 4. Then the biggest number is going to be 4. And it would start at negative infinity. Now, is the 4 included on this one? Yes. So what goes there? Bracket. Because it's included. And then when you go to your number line, 4, 5, 6, 3, 2, 1. We're going to use a bracket on the 4 and then shading to the left toward negative infinity. Bracket on the 4 going to the left.
Okay, I hate to ask. How do we know the 4 was included?
The equal to mark on the inequality symbol, that bar underneath, means it's included. And that's how you're going to know. If it's got that equal to mark, you know your interval notation is going to have a bracket and that number is included, whatever you get for the solution. If it does not have the equal to mark, then it's not included, which means parenthesis on the interval and the graph. Okay. Good question. That's an important thing. Example C, 4 minus 3x less than or equal to 7 plus 2x. What could we do on this one? That's one possibility. We'll do that. That'd be 4 minus 7 would be negative 3 minus 3x less than or equal to 2x. Then you would add the 3x. Good. Negative 3 less than or equal to 5x. Last move. Trying to get x by itself. Divide by 5. Why did I not flip the symbol? Didn't divide by a negative. Divided into a negative, but that doesn't matter. What matters is the number that's in front of the x. Okay. Now, when you go to rewrite this in your set form, let's turn it around to where the x is first. So if it's opening, this way toward the x, it's written that way. When you flip it around and put the x first, it still needs to open toward the x and point toward the negative 3/5. And that's the most accepted way of writing it in set notation. Let's put the letter first, if that's the only thing that's happening. In the interval notation, is it included or not included? Included. So we know we're going to use a bracket on the negative 3/5, and then all the answers are bigger than that. So we're going from negative 3/5 to infinity. The bracket on that. X is greater than negative 3/5, so that's we start here and go towards positive infinity. And then on the number line, negative 3/5. If I put that in the middle, think about negative 2/5, negative 1/5. I could go negative 4/5, negative 1. Almost wrote it. All right, and then bracket and go toward positive infinity, which would be to the right. I did mine with fractions in there. If you wanted to have negative 3/5 in the middle here, and then put 0, 1, 2, and then negative 1, negative 2, that direction, that's okay too. But I just kind of took the most common way of doing that with as far as just this textbook goes. Okay, so not too bad.
So we're answering the question, would ask for a specific way.
Yes, it'll say, write this answer in a graph or as a interval notation or set notation. It'll ask.
It'll be specified.
Yes, it'll be specified. And on the Blackboard assignment, there's a few questions where it just gives you an inequality like this and says which one's the graph for that, and which one's the interval notation for that. So it just like takes one of the, and then I think there's a couple that actually give you the interval and say what's the inequality for that, or the set notation for that. So, but it will specify which way to get that answer. All right. One more. Excuse me. Example D, I guess, yeah. All right, let's see one where we have what's called a compound inequality. We've got the x in the middle, kind of like two inequalities in one. But mathematically, it works the same way. You just got three spots to deal with. So if we want to get x by itself in the middle is what we're after here. So we want to move things that are not x's out of the middle. So that 5, we got to get rid of it. How do we get rid of it?
Subtract.
Yeah, subtract it. If I subtract it from the middle, I got to subtract it from the -2, and then I got to subtract it from the 20 on the other end. All three spots. So there's 3x in the middle, almost x by itself, not quite. And then -7 on the bottom end. And then one more move gets x by itself. Divide everything by 3. And if it helps, I mean, you can just like cover up this end, and whatever you would do that direction, you got to do on this end too. Okay, so like if you worked it like by covering up this part, and say, okay, how do I get x by itself with just the right hand inequality? You do the same thing on this end too. Whatever you do to one spot, you got to do to all three spots for these. And then we get a fraction on one end, which is not a big deal. And then 15 divided by 3 is 5.
Basically, all we're really doing is simplifying the problem.
Yeah, and just getting x by itself. Yeah, and simplifying it so it looks a little bit, it's easier to graph and easier to write an interval notation of that. Okay, so are either of those values included? No. Okay, so we know when we write this in interval notation and on the graph, it should be parentheses.
Why are they not included?
Not because it's less than, but it doesn't have that equal to sign underneath. Good job. That's right. It doesn't have that bar underneath the inequality symbol. If it was included, it would have that symbol underneath it. That's what's going to tell you.
Basically, if the 5 had the equal to symbol, but the 5 would be included.
Right. It could have one have it and one not. That's possible. Yeah, absolutely. Good question. Good looking out, I guess. Yeah, you could have a parenthesis and a bracket. We'll do another example. Maybe it does that. It doesn't complicate it very much at all, but it just makes it where you got both of them. All right, so there's our, the set builder. Heck, you can just build that around that if you want to, because that's what it is. You just put your brackets and the bar and the X, and you're in set notation. And then to get the interval notation, we got parentheses, and then the smallest number is -7/3, and it goes to 5. We don't have an infinity in this one. And then when you look at your graph, they got to be a little bit more, you got to think a little bit more when you draw this graph, because you got to go from -7/3 to 5. So I'm going to, 6, 5, 4, 3, 2, 1, 0, -1, -2, and then -3 is right there, -4. Where is -7/3 at on that number line? I'll scroll to where we can see that. 2.3. All right, so it's negative 2.3. So is that between negative 2 and negative 3 or negative 2 and negative 1? Yeah, between the 2 and the 3. So that's about right there. And then we would put a parenthesis right there. And then a parenthesis at the 5. And then kind of darken that line in the middle.
So on the number line, all it does is just give you 2 endpoints.
Yeah, when it's a compound one like that,
So
yeah.
it's just like a beginning.
Mm-hmm. Whereas the first 3 examples didn't have an ending spot because we went to the infinities with those. Okay, so I think the compound ones, other than the kind of confusing solving part, the graph's a lot easier to read, in my opinion. So let's look at one more of those. Let's say we had 16 is less than or equal to, 2x minus 4 is less than, let's make it a good number, 18. All right, so we want to get x by itself in the middle. So what's our first thing to get rid of in the middle? The negative 4 there. So how do we get rid of it? Add it. So if we add 4 in the middle, you got to add it all over the place. So that'd be 20 and then 2x. No equal to on that second one. And then 22. Well, that works out real nice. Because now what? Divide by 2. There's x by itself in the middle. Do I need to flip my symbols in this problem? When would I flip my symbols? If there was a negative that I'm dividing or multiplying by. So be careful about that. So this one doesn't do that. Just make sure. You would flip both of them. Both of them would flip. With the compound inequalities, they're going to be facing the same direction. Like here, less than, or greater than. It's going to be the same direction with those. And so that makes it pretty easy. It's in the right order. Interval. There's our set. Interval, which one's included? The 10 is included because it has the equal to mark. So that would be 10, 11, parenthesis. And then the number line's a little easier on this one. A little short, but hey, no big deal. We'll make it look like it's really bracket on the 10, parenthesis on the 11. Darken those in a little bit. And then line in the middle. Looks like a lot of numbers in there. There are. Maybe not as many as some of the others we've done. Okay. So section 1.7. All of those things is what 1.7 is about. All right. The problems that you can look at for 1.7, I'll go ahead and write that down. 145, page 145, numbers 1 through 37. Some good ones to practice on with that before you do your blackboard assignment for that. Okay. Not bad. So quick lesson there, and then let's go ahead and get to our next one. Section 2.5, equations of lines. So this one's a little bit more involved, but it goes back to those equations of lines like we were dealing with in Lab 11, where we were, we had slope-intercept form, that sort of thing. We're going to get that. What we're going to do is we're going to be able to write an equation given some information about it in several different forms. So let's look at point slope form first. Point slope form. Point slope form is a pretty descriptive form it has a little bit more stuff in it than slope-intercept form. It's still got a slope in there. The only thing it doesn't have is necessarily a y-intercept listed. If you remember, the last question on Lab 11 was written in that form, and you were asked what the slope was of that line, or the y-intercept of that line, whatever it asked for there. It was written in that form, but we didn't call it that. We just said get y by itself. So we're going to start with this form, and what we're going to do is take this form and then morph it into slope-intercept form, and then take slope-intercept form and morph it into this thing called standard form. But it all stems off of this and getting that stuff right. So what we have here is we have the slope, the same slope that we dealt with last week. M equals y2 minus y1 over x2 minus x1. And then this, the x and the y, the x1 and the y1, that's an ordered pair that you're going to be given. Okay, they're going to give you at least one ordered pair and a slope, or they may just give you two ordered pairs and say find the equation of the line. We're going to see all of those different scenarios here out of that. Now, this y and this x, they're y and x. They're the y and the x that's in the problem. Okay, will you have the formulas? Yes, I will actually give you the formulas for the final exam. That's what you mean. Yeah, on the final, you'll have the formulas. And I'll probably give them to you on the exam next week as well. Mm-hmm. Exam next Monday. All right, let's look at some examples of how to use this. Example A for this section. Let's write the equation of the line in point slope form. So I'm telling you what form we're going to write it in here. And then later on, we're going to do different forms. So point slope form through, and here's the ordered pair given to you. And it's a through -4, 1. That's a -4, +1 with slope of -3. Okay. So we're going to write the equation of the line given that information. All right. So we know this -3. They said that's the slope. So what's that going to be in my point slope form? It's my m. It's my slope. This -4 and this +1 are what? At y and x. So they're y1 and x1. x1, y1. Okay. And then all we're going to do is plug that stuff in. That's all we have to do if they ask us to write it in point slope form. So we're going to have y minus the y value. What's the y value from that ordered pair? 1. So y minus 1 is equal to the slope, or slope for this problem is -3, parentheses, and then we need x minus -4. The only thing we need to do is simplify if we can to get it in point slope form. Yes. Given a slope and a point. So that's going to be y minus 1 is equal to -3. What can I turn that parenthesis into? Instead of x minus -4, it would be x plus 4. Two negatives make that a positive. So that is the point slope form of that line. It really is all there is to writing it in point slope form.
It really sounded bad when you were going over it.
But it's not. There's a lot of parts to it. But they're going to tell you all of them. That's the thing that you got to get, is that, it's not that complicated, because they're going to have to tell me enough stuff to be able to write this. If they don't, then I can't do it. So they're going to give you enough information. So here we're given a point and a slope and asked to write it in that form. Let's look at the next one. Example B, let's write the equation of the line in point slope form. We're not going to waste time writing that whole big long sentence there that goes through -3, +2, and 2, -4. Uh-oh. They didn't give us everything. They didn't give me a slope. But they did give me 2 ordered pairs. I got to find the slope using the slope formula that we already know. M equals y2 minus y1, x2 minus x1. So we're going to plug that in and find the slope. So what goes on the top? -4 minus 2. On the bottom, 2 minus -3. Taking our y values, putting them up top and subtracting. Taking our x values in the same order and subtracting them. So -4 minus 2 would be -6. -3 minus, or 2 minus -3 would be 5. We get -6/5 is the slope. Okay. Now here's where the point slope form can get a little bit different for each person. How many ordered pairs do we have? 2. That means we could have 2 different answers and both be perfectly correct. Okay. The slope for everybody is -6/5, no matter which point you pick. So the slope is stuck at -6/5. The point you use makes a difference. So if we chose to use the first point.
So when you come to a problem like this, you have to find the slope first and then work the problem out twice using both order pairs.
No, if I'm going to ask you to do this in point slope form, I'm probably going to tell you which ordered pair to use.
But if it didn't, you have to work.
You would, yeah, and pick out,
one.
and pick out which one was the right one. Now, when we go to slope-intercept form, there's only one answer, no matter which point you get to, and we'll see that in just a second. Okay, so if we pick the first ordered pair, -3, 2, to use for this, I'm going to have y minus the y value, 2, slope, -6/5, and x minus the x value. That's if I pick that ordered pair. And then I'm going to simplify that the same way we did example A. So that'd be y minus 2, -6/5, x plus 3. That's one possible solution to this. What if I use the other ordered pair, 2, -4? There you go. And then simplify that. I plus 4 equals -6/5 x minus 2. Those are the same equation, honestly. If you graphed both of those, they'd lie right on top of each other. They're the same graph. Even though the equations look different, they're the same graph. So depending on which ordered pair you pick, which one of those point slope forms you're going to find. Now, point slope form is great, but like we see here, you could have 2 different answers and both be correct. So then we move on to slope-intercept form is the next thing we're going to talk about. So there's point slope form. Those are the scenarios you're going to get. You're going to get a slope and a point, plug it in, simplify it. Or you're going to get 2 ordered pairs, find the slope, and then pick a point and get your equations of lines. Okay, so those are the scenarios with point slope form. The same scenarios come up with slope-intercept form. There's no difference. Okay, the only difference is getting there. So slope-intercept form. Let's review it real quick. Yes, ma'am.
And then the other one, the 2 order pairs.
Find the slope first.
And hope they tell you which pair it is.
Yeah. And then pick an ordered pair. Plug it in and simplify. All right. Slope-intercept form, we've seen this before. We talked about it earlier. Y equals mx plus b. Nothing different about that. The slope is still m. That b is still what? The y-intercept. Okay, always going to be that when it's in slope-intercept form. Notice that y is by itself here. We don't have any parentheses going on when it's in slope-intercept form. That's the key. All right. So let's look at a problem, the scenarios that could happen with slope-intercept form. Excuse me, based on what we know we need. What two important pieces of information are there in that equation? Slope and a y-intercept. So that's the first scenario that can happen. They could tell you to write the equation of a line in slope-intercept form that goes through 0, 6 with slope -2. How do I know that 0, 6 is a y-intercept? Very good, Lindsay. 0 is in the x part. So that means that's on the y-axis. So that means b for this equation is what? 6. All right. So slope-intercept form. There's the y equals. What's the slope of the problem? -2x. And then that's a +6. So that's going to be +6. You've written it in slope-intercept form. That's the easiest scenario. It's not the one that's going to happen the most. It's the easiest one, though. Yeah, no, you know it's not going to work that way. This is a math class, so we can't make anything easy, right? So, given a slope, given a point, easy enough. All right. Now, that should look familiar. Through -4, +1 with a slope of -3. Look at example A. It's the same one, okay? Now, why did I use the same one? Because I want to get you the connection between point-slope form and slope-intercept form. That if you can start with point-slope form, slope-intercept form is super easy from there. Okay, so we already have the equation for this problem in point-slope form. From example A, it was y -1 -3 parentheses x plus 4. Now we got that from example A. From example A. That's where we know that from. If we didn't get it from example A, it's not that hard to get it there anyway. Because y minus the y value equals the slope, parentheses, x minus the x value. Okay, now, to get that in slope-intercept form, what has to be by itself? Y. So, let's get y by itself. Not yet. What do we have to do first? Distribute the -3 first, yeah. -3x minus 12. This is still y minus 1 over here. Now we can add 1 to the -12. Hey, we got y by itself. And then the y-intercept would be -11. And there we have slope-intercept form. But we started with point-slope form. Okay. Excuse me. All right. So let's look at another one. And say, the scenarios we're given so far. Slope, given a y-intercept. Given both of those. Second scenario is here, given a point and a slope. we work it through point slope form into into slope intercept form. Okay. Next scenario, through, let's do -3, 2, and 2, -4. Should be familiar. That's example B. But let's work it from scratch. Let's just say, okay, well, I don't remember doing that problem, so I'm just going to rework it. Okay, so what's the first thing I need to find if I'm going to write this in slope-intercept form? Slope. If I'm going to write it in point-slope form, the first thing I need to find is slope. If I'm going to write it in slope-intercept form, the first thing I need to find is the slope. You got to keep, it's linear stuff. The slope is an important thing. So let's find the slope. -4 minus 2, 2 minus -3 would be -6/5. Should be familiar slope. Now, the next thing I'm going to do is I'm going to pick one of those points to use and go to point slope form. Okay. So, which one do y'all want to pick? 2, -4 looks like a good one. It doesn't really matter. I'm going to pick that one. So, that'd be y plus 4 is minus -4, turns to plus. And then the -6/5. And then x minus 2. Got a few fractions to deal with here, but that's okay. It's not going to be a big deal. Should be able to crank that out a little bit. Now, if I want to write that in slope-intercept form, what do I have to get by itself? Y. So what am I going to do first? Distribute. So that's going to be -6/5x plus, that'd be 12/5. -6 times -2 is positive 12. Then it's just over 5 times 1 is 5. One more step gets y by itself. Subtract 4. Y is equal to -6/5 x, and then let's see, that'd be -20/5. That'd be -8/5. And there we have slope-intercept form. Check me with the calculator there. I'm subject to making mistakes this late at night.
So how you work that fraction is you put 4/5. You pretty much multiply 4 by 5.
Mhm.
12.
Yeah.
Okay.
Yeah, that's exactly what I did. Because that's 4/1 multiple. And I'm fine with you doing that with the calculator. It doesn't bother me. It used to bother me. I've gotten over that. So, all right. So there we took that problem. Now, even if we use the other ordered pair, we should end up with the exact same slope-intercept form. Okay? That's what I want you to understand. It doesn't matter which ordered pair you pick. You're going to end up with the same slope-intercept form. If you and somebody else is working, practicing, working together, and one of you does with this point, and the other one does with the other point, you should end up with the same slope-intercept graph or equation, and technically the same graph on that. Okay. All right. Let's look at the next form. The next form is called standard form. Okay, so we've taken the scenarios, not standard form of what are the scenarios they could give us. Well, they gave us a point and a slope. You get point slope form. They gave us 2 points. We got point slope form out of that. They gave us the slope and the y-intercept. We got slope intercept form out of that. They gave us 2 points. We got the slope intercept form out of that, but we went through point slope form. Standard form, you don't have y by itself. It's a little different. I'm not sure why they call it standard, other than maybe this is the first way they wrote it. I don't know. It looks like this: ax plus by equals c. And there's a few rules to this. Well, one rule to this: a, b, and C, and I use the Oxford comma. If your English teacher tells you not to, take that up with them, are not fractions, which everybody should shout hooray for that, because you don't want fractions in your standard form. Slope-intercept form, point-slope form, fractions are kind of commonplace. In standard form, you don't want fractions at all. You also, kind of a side rule here is that A, B, and C can't be divided by the same number. Like you couldn't have a 2, a 6, and a 12 as A, B, and C because they're all divisible by 2. So you'd want to simplify and divide everybody by what they're divisible by. So that doesn't come up a whole lot. The fraction stuff kind of takes care of that, really, honestly. So now, with the standard form, what we're going to do is we're going to work our way through point slope into slope intercept, and then from slope intercept into standard, because slope intercept is almost standard form. If you think about it, if I just subtracted mx, there I have negative mx plus y equals b. That looks a lot like standard form. X and y are on the same side. So that's what we're going to be doing here, is getting the slope intercept form and then moving that into the standard form. Okay, so let's start with just an example. It's got some numbers in it, so it actually makes some concrete sense. With that, I have no idea what letter we're on. F. It's fitting. All right, so let's say we had an equation. So put y equals negative 3x minus 11 into standard form. So let's start with that type of problem. So when I look at that, I notice x and y are not on the same side. Standard form, x and y are on the same side. So I need to move the 3x. How do I move it? Add 3x. So that's going to give me 3x plus y negative 11. X and y are on the same side. Are there any fractions? Not any fractions. Is there something that goes into 3, 1, and negative 11 that would reduce the problem? No. And we're in standard form and we're done. So if you can get the equation in slope-intercept form, standard form is usually 1 or maximum 2 steps away. Okay? So if we can get slope-intercept form, standard form is super easy after that. Okay, let's look at another example, maybe a little bit more difficult. But let's put y equals negative 6 over 5x minus 8 over 5 in standard form. Well, put that in standard form. Can't have fractions, but we'll take care of that in a minute. Let's get the x and y on the same side first. How do I get negative? Not doing that. Add the x part to the other side because it's a negative 6 over 5x. So to move it to the other side, we're going to add it just like we did up here. We added the 3x to each side here. We're going to do the same thing here. It just so happens it's a fraction, but that doesn't affect process. It affects, kind of semantics there of what you're going to see. But so here we have a fraction, and we need to get rid of that fraction. So what we want to think about anytime there's fractions in it and we're trying to get it in standard form is what's the common denominator of those fractions. What would be the common denominator between 6 over 5 and negative 8 over 5? 5. So what we want to do is multiply that entire equation by that common denominator, 5. 5 times 6 over 5x, 5 times y, 5 times negative 8 over 5. Well, when I multiply 6 over 5 times 5, The 5's cancel, right? And all I've got left is 6x. 5 times y is 5y. 5 times negative 8 over 5 be negative 8, right? And lo and behold, we're in standard form. So the fractions in there, they're not too bad. You just got to think, okay, well, what do I got to do to get rid of them? And the thing to do to get rid of them is multiply by the common denominator. They won't always have the same number in there. We'll do some more examples here in just a second. But so sometimes we've got to think a little bit harder than we did on that one to get them there. Okay. All right. So let's take a problem and do all of the forms for it. So just from scratch, new problem, and get all of the forms: point slope, slope intercept, and standard. And you want to do them in that order because that's the easy order to go in. All right. So example H through 1, 1 and 2, 4. Let's first do point slope. And this is kind of how you would want to go about doing this when they're asking you to write the equation of a line. I'm going to start with point slope form and then get it in the form that they ask for. They may ask for it in standard form. They may ask for it in slope intercept form. Or if we're lucky, they ask for it in point slope form and we can stop there. But you won't be that lucky a whole lot. Just because you don't. Slope intercept form is the most common form that you'll use. Standard form is second most common. Point slope is, like, for some reason, the least common. All right, so what do we need to write the equation of this line? Slope. So let's get that first. 4 minus 1, 2 minus 1. The slope of what? 4 minus 1 is 3 over 1 would be 3. So there's our slope. Now we need to pick a point to use. Does it matter which one? No. Pick the one you think's the easiest. There's one that's got a lot of, 1, 1 is what I'm going to pick, no doubt. But if there's negative signs in one of them and you kind of struggle with positive and negatives, then avoid that ordered pair. Pick the one that you think's the easiest for you. Okay? So your point slope, you could have y minus 1 equals 3 parentheses x minus 1. Or what's the other equation? Just to make you think a little bit. I scrolled past the ordered pair. It'd be y minus 4 equals 3 parentheses x minus 2. Either of those. Again, I'm going to pick this one because it's got ones and I can't screw it up. I can't put something in the wrong spot. Hey, if it's a double number there, but understand either of those would be correct for point slope form. Okay. Once you get point slope form, you want to take one of those and go to the slope intercept form. Okay, since it's already in point slope form, let's work it out to get it in slope intercept form. So that just means we got to get y by itself. So what's our first step? Distribute. It'll be 3x minus 3, y minus 1, and then add 1. 3x minus 2. If you did the other equation, if you're a rebel, it works the same way. Y minus 4, 3x minus 6. You only have to do one. I'm just showing the other one just to show you that, hey, it ends up the exact same equation. No different at all, no matter which ordered pair I use. So that's maybe a good checking thing that you can do. If you're not sure of yourself, well, if I work it the other way and I get the same answer, it's very likely that I didn't make the same mistake twice and get, and still end up with the same answer. So that's a good checking spot. So once you get slope intercept form, that's really easy to get into standard form. Okay, so step 3, standard. Okay, so we got y equals 3x minus 2. What do we need to do to get that in standard form? Subtract the 3x. Cancels out. Negative 3x plus y is equal to negative 2. No fractions. They're not all divisible by the same thing. But I'm going to throw a kink in it. Why are those the same? So did just the 3 and the 2 change signs?
No.
All of them change signs. So understand that these are equivalent equations. This is, by rule, standard form. And that's correct. But when you're looking at a multiple choice type situation, they may not have this. They may have that as an answer choice. And they're equal because you just change all of the signs. You can't just change one part, you got to change everything. You're going to change that.
So let's say that the one you had squared in was answer on the test. If we got the other one, would we just be able to pick the other one?
Yeah. Well, if this is not an answer choice and this one is, but when you worked it, you got that. Understand that if you change all of the signs, it's that one. Yeah, that's equivalent equations or equivalent expressions is what you would call that. Just change the sign of everything. Everything's the same. Okay. All right. So there we have point slope form, standard form, and slope intercept form all in the same problem. So we should be able to take situations that we've been given and get whichever form they're asking for. I'm not going to ask you for all 3 forms on the blackboard assignment or all 3 forms on lab. Okay. It's going to be one of those forms. Okay. All right. Let's get the next thing in this section. The next thing is just taking this information we just talked about and applying it to parallel lines, and then we'll apply it to perpendicular lines in just a second. Parallel lines. What do we know? What do y'all know about parallel lines? They run side by side, meaning that they never what? Never touch. Okay. Better mathematical term would be never intersect. When we start talking about the equations, they have the same slope. Same slope. That's the big one. That's the thing that we're going to play off of here. If 2 lines are parallel, they're going to have the same slope. Okay. So what we're going to be given here is, excuse me, example I. Is this example I? Okay. Is they're going to give us a situation and want us to write the equation of a line that goes through this ordered pair, 3, 5, that's parallel to 2x plus 5y equals 4. Okay. And we're going to practice and put in all 3 forms. Okay. All 3 forms. So we're going to write the answer in point slope form, in slope intercept form, and in standard form. Okay. So parallel to, when we see that word, parallel to, we know we got to steal a slope from somebody. We got to steal it from that equation. So to get the slope of that equation, 2x plus 5y equals 4, what do we need to do to that equation?
You gotta get y by itself.
All right, so we got to get y by itself. So how do we do that? Subtract the 2x. Good. That's 5y equals negative 2x plus 4. And then what? Divide by 5. Everybody divided by 5. Negative 2/5 plus 4/5. What part of that matters? The negative 2 over 5 is the only part we care about for that. That is going to be the slope of my new line, is the negative 2/5. Okay, that's the only part I care about. Parallel lines have the same slope. So we get the slope from the equation it's parallel to. And that's what we need to get out of this. All right, so let's start with point slope form. So y minus 5, negative 2/5, x minus 3. Any simplifying that needs to happen on that to get it in point slope form? Scroll up a little bit so we can see. Is that point slope form? Y minus the y value, that's 5. The slope, x minus the x value. We're in point slope form. Now, let's take that and get in slope-intercept form. Slope. Now, what do we have to do to the point slope form to get in slope-intercept form?
Get what?
Go ahead.
Oh, so whoever said first started first.
It doesn't matter. I don't care which way. What were you going to say?
Get y by itself.
Get y by itself, and to do that, say, add 5. We can't do that yet.
Distribute.
Got to distribute first and then add 5. Okay, so we're going to have y minus 5 is equal to negative 2/5 x plus 6/5. There was a fraction there, but that's okay. Not a big deal. Now we're going to add the 5 to the 6/5. And that would be 25 plus 6 be 31/5. And then standard form. Check me. Did I get 31/5? Is that right? Some of y'all are using calculator to check stuff. 6/5 plus 5. Is that 31/5? Okay. Good deal. So let's go standard form to get that last form. Because I'm doing all 3 forms because I don't know which one it's going to ask you for. It could ask for any of the 3 forms. I did.
6 by the 5 and then add 5.
So 5/1 turns into 25/5 because the common denominator would be 5. 5 times 5 is 25. 5 times 1 is 5. 25 plus 6. 31. All right, standard form. So we're taking our slope-intercept form and doing what? Getting the x and y together. So how do we do that? Yeah, add whatever move the x stuff to the other side. We're adding it on this case. That's 2/5 x plus y for 31/5. 5 looks goofy. Let's fix it. And now, what rule is this in violation of? Got to get rid of the fraction. So what do I multiply by to get rid of this fraction? 5. Everybody gets multiplied by 5. The whole problem is what I'm saying right there. With that notation, I'm saying multiply everybody by 5. 5 times 2/5 would be 2x. 5 times y would be 5y. 5 times 31/5 would be 31. And there's our standard form. So there we've taken a parallel situation. They said, okay, here's the point. Our new line's going through, and it's parallel to this equation. Get your slope of your line it's parallel to, and then do the same thing again as we've been doing. Okay? Point slope, slope-intercept, standard, whichever form they ask for. All right? There's parallel lines. Parallel lines have what? Same slope, always, forever. Never going to change. Parallel lines have the same slope. All right, let's look at perpendicular lines. What makes 2 lines perpendicular? Absolutely, perfect. The perpendicular lines cross and they make right angles. when they cross, 90-degree angles there. So they do intersect at 90-degree angles. Well, you got to figure, we talked about parallel lines and they had the same slope. Perpendicular lines obviously cannot have the same slope because they're going to intersect. Parallel lines don't intersect. So the perpendicular lines, the slopes are opposite reciprocals. Opposite reciprocals. That means flip and change the sign. Okay. Flip and change the sign. Okay. Perpendicular lines have opposite reciprocal slopes. Okay, so whatever the slope of the original line is, flip it and change the sign. So, J, maybe? Guessing on the letters? Or is, hey, awesome. Good guess. 1 in 20, well, a little better than 1 in 26 chance. All right, so let's say we had through 3, 5, perpendicular to 2x plus 5y equals 8. Okay. We want to write the equation of the line in all three forms for this. Perpendicular to. So what do we need out of that equation? The slope. How do we get that slope? Move it to slope-intercept form. So how do we move it to slope-intercept form? Move the 2x by subtraction. 5y equals negative 2x plus 8. Divide by 5. What part of that do I care about? The negative 2 over 5x, the slope. Okay. Now, what I need to think about here is what's my perpendicular slope? Positive or negative? Positive. Flip it and change the sign. So the slope of our equation that they gave us is negative 2/5. The perpendicular slope, flip it and change the sign. So turn it over, 5 over 2. It was negative, make it positive. That's going to create the 90-degree angles in the coordinate plane that we need to be perpendicular. Flip it, change the sign. So if the original slope is negative, the perpendicular slope will be positive and flip it over. If the original slope was positive, the perpendicular will be a negative slope flipped over. Okay. So let's take that information and let's write the equation of the line in all those forms. So point slope. Should be getting a little bit better at this. So what's our point slope form? Equals 5 over 2 parentheses. You tell me. Right. Yeah. That's always, this is going to be the flip, the original slope, flip it, change the sign. Then it's always minus signs here. If one of those is negative, then the double negatives make it pluses. So neither of those are a negative number. So that's point slope form. Yeah, nothing to simplify. Good. Now, let's get that in slope-intercept. Slope-intercept form means get y by itself. So what's the first thing I should do to my point slope form? Distribute, yes. We're getting better at that. You don't have to think too hard. One more. So 5 times 3 be 15 over 2. Then I would add the 5. Plus 5. So that's 25 over, not 25, 10 over 2. And then be negative 5 over 2. There's slope-intercept form. All right. Are you with us on point slope? Right here? Okay. So we distributed 5 over 2, and that's where we ended up here. 5 over 2x, and then 5 times negative 3 is the minus 15, and then over 2. Okay. And then the last thing we did was we added 5 to get y by itself. So negative 15 over 2 plus 5. And I just changed 5 to 10 over 2 so I could do it without a calculator there. But you're welcome to use a calculator. Encouraged to use a calculator if you need to. All right. Now, that's slope-intercept form then. Let's get it in standard. What do I do? Minus the 5 over 2x to get the x and y on the same side. Now what? 2. Why are you multiplying by 2? Yeah. Common denominator, get rid of the fractions. So I'm multiplying everybody by 2. It gets me negative 5x plus 2y equals negative 5. How else could that be written? What's the or equation that could be? Good. What did he do to that? Changed all the signs. Okay. And there's no real way of, I can't say that it's 100% always going to change all the signs if the leading term is negative. I can't say that 100% of the time because sometimes it does. Sometimes they do, sometimes they don't. Just one of those things. You got to be able to just recognize, hey, I could just change all the signs and it work out there. Okay. All right. Questions about parallel or perpendicular lines? Okay. So section 2.5 on page 226. 1 through 51. Yeah, I'd suggest the odd ones there is what I would suggest. So here's the plan of attack for next week. We'll come in, we'll do labs.